This is problem number 1 for assessment number 8. It says find the area of the region enclosed by the curves y equals x squared minus 6x and y equals negative x squared plus 4x. So the first thing we need to do is we need to figure out where do they actually intersect each other? Where does this function intersect this function? That way we can see what our endpoints are for our integral. And then we need to figure out which of these functions is larger in between those roots. So let's start out by taking x squared minus 6x and setting it equal to negative x squared plus 4x. If we go ahead and solve here, we can add the x squared over, subtract the 4x, we get 2x squared minus 10x equals 0. And then we can factor out an x, so we get x, actually just factor out a 2x, so 2x, and that leaves you with x minus 5 equals 0. So we have 2x equals 0, or x minus 5 equals 0. Divide by 2, we get x equals 0, or x equals 5. So we only have two roots that they share in common. That makes sense because we have a parabola and another parabola. So because we only have two roots, we're really going to integrate only from 0 to 5. But what we need to do is draw a number line and figure out which function is larger between 0 and 5. So let's just pick a number in between here. I think 2 works pretty well. So we're going to say for 2, f of 2 equals, and I'm going to call this f of x, and this g of x. So f of 2 is going to be 2 squared minus 6 times 2. 2 squared is 4 minus 12, which is negative 8. So the f function gives you negative 8 when you plug in 2, which is between our roots. The g function, g of 2, is going to be negative 2 squared plus 4 times 2. Well, that's negative 4, because 2 squared is 4, negative in the front, plus 8, which is 4. So we can clearly see that this function here is the larger function between these two spots. So we're going to say that g of x equals negative x squared plus 4x is larger between x equal 0 and x equal 5. So because we know it's larger, we can go to our f of x greater than or equal to g of x throughout this AB, so throughout this interval 0 to 5, they're continuous there. Then this larger function, we're going to take subtracting the smaller function, and we're going to integrate it from our x values, which are 0 to 5. So we're going to say that this is we want to do the integral from 0 to 5 of the g of x function, so negative x squared plus 4x minus x squared minus 6x. And we want to do that with respect to x. We need to do some algebra in here first. So we're going to do integral 0 to 5. And this will give you negative x squared plus 4x minus x squared plus 6x dx. Combine some stuff together here, and we'll get integral 0 to 5. That'll be negative 2x squared plus 10x dx. Do the integral now, and we'll end up with, if we add 1 to this, that's x cubed divided by 3, so we have negative 2x cubed over 3. We add 1 here, we get 2, and then divide by 2, so x squared over 2, so we'll get plus 10x squared over 2. And we're going to integrate that, or not integrate that, we're going to evaluate that from 0 to 5. So now let's plug all that in. We get negative 2, 5 cubed over 3 plus 10 times 5 squared over 2 minus, when we plug 0 into each of those terms, we get 0 there. 5 cubed is 125. So we have 125 times negative 2. So we get negative 250 over 3. And then 5 squared is 25. So 5 squared is 25 times 10. That's 250. So we have plus 250 over 2. If we go ahead and just throw this in the calculator, make it easy, we'll get negative 250 divided by 3 plus 250 divided by 2. And convert it to a fraction, we get 125 over 3. So our area between these two curves, f of x and g of x, is 125 over 3.